Welcome to the organic loading to a trickling filter math problem. I'm going to talk at you for a quick minute before we jump in about I'm going to set up a premise here. First, this is covering all 5 grade levels, or in your state, all 4 grade levels or whatever it is that you guys do. So this is beginner all the way to advanced. We're going to start with the beginner math problem. This is actually built more like an advanced math problem, but I'm going to show you beginners how and entry level folks how you're just going to solve this actually fairly quickly. And then for the advanced folks, stick around. I've written one question already, but I'm going to give you a couple scenarios they're going to ask. So when you do these math problems on the advanced tests, oftentimes you get your problem done, and then you click to the next screen if you're doing the computer-based module, and they're going to start asking you questions about that math problem. Okay, so be ready for that stuff. It doesn't always happen. Actually, on my grade 3, it was just bam, 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 bam. Math problems, but on my grade 4 it was math problem, and all of a sudden there was a quiz on the math problem I just did. They're going to ask questions. So stick around if you're a higher level test taker for that. Also, this is at the very end of this video, a video will pop up on your screen, and that is the trickling filter video I did about 2 weeks ago. It's about 20 minutes long. If you don't work in a trickling filter plant, I highly recommend you go watch that video because I take you around my trickling filter and then do a really I think thorough exam prep whiteboard at the end. It's about a 10-minute long whiteboard segment that I think was very helpful for you. Also in the links below, real quick, before we jump into this, hydraulic loading to a trickling filter is up. I'm going to put it in the description. And then also the pounds formula. If you're unaware of how to do a pounds formula, we do it in here. And you need to know how to do that. So there's 2 different videos I did, one with a shortcut, one without a shortcut. If you've never done this before, you should watch the one without the Davidson Pi first, and then go learn the shortcut. And then, okay, that's my little talk, my little introduction. So let's jump into this. The wastewater treatment plant has a trickling filter with a flow of 1.2 million gallons per day. The plant influent BOD measures 300 milligrams per liter and 250 milligrams per liter TSS. The primary effluent is 150 milligrams per liter BOD and 100 milligrams per liter TSS. The trickling filter is 65 foot in diameter and 10 foot deep with a 2-to-1 recirculation ratio. What is the organic loading rate? So organic loading to a trickling filter is pounds per day per 1,000 cubic feet. That's what you're looking for. Now, something to be aware of and how this differs from hydraulic loading is organic loading does not include the recirculation. Okay, this is a smoke screen. 2-to-1 recirculation ratio. Nope. The organics have already been counted. 150 milligrams per liter has already been counted in the primary effluent. And you might ask yourself, well, hasn't the recirculation flow already been counted on the hydraulic loading? No, it hasn't because it's hydraulic loading. It's a different measurement. Okay, it's a totally different type of measurement. So organic loading, you only count the BOD one time. The hydraulic, however, you're reapplying water hydraulically, and so you count it again when you're doing a hydraulic loading rate. Okay, if you are out there and you're watching this and you have a better way to explain it than I just did, please put it in the comments below to help people. But please know, organic loading, you only count the flow once. You don't use recirculation. So this is a smoke screen. Or on hydraulic loading, though, you do. Okay, big difference. Okay, so I got my flow, 1.2 MGD, million gallons per day. All right, I need to do a pounds formula. Well, I've got a bunch of stuff here to do a pounds formula with. Which do I choose? Well, the primary effluent is the one I choose. And the reason why is, if you watch my trickling filter video, trickling filters are not designed to go straight with raw influent. That's not their design. They typically, I'll always say typically, because no rules 100% all the time, but they typically, 99% of the time, need a primary clarifier or something of that nature. So you're going to be using the primary effluent when you are given it. Also, with activated sludge, same thing. You can do activated sludge without a primary clarifier, but if they give you primary effluent numbers, you use those because there's a process between the raw influent coming into the plant and the actual secondary process, and that's the primary clarifier. So we're doing organic loading, which I know is pounds per day of BOD per 1,000 cubic feet. So there it is, 150 milligrams per liter BOD. That's what I pull out. I don't need any of this stuff. TSS is irrelevant, and I don't need my plant influent. I need my primary effluent, BOD. They might also write it that the BOD measures 300 milligrams per liter coming into the plant, and the trickling filter influent is 150 milligrams per liter. So the primary clarifier effluent and the trickling filter influent are the same thing, okay? For this math problem. Okay, 150 milligrams per liter is what we got. Our flow is 1.2 mgd. I can do a pounds formula. So 1.2 mgd times 8.34 pounds per gallon times 150 milligrams per liter is 1,501 pounds per day. Okay, so I've got my pounds. Pretty simple. Now I've got to get my cubic feet. All right, so I've got the trickling filter is 65 foot in diameter, 10 foot deep with a 2-to-1 recirculation ratio. We've already decided 2-to-1 is worthless to us. Get it out of here. Cubic feet. I like 0.785 diameter squared. That's my flavor. So 0.785, 65 foot squared times 10 foot. If you plug that in your calculator, you should get 33,166 cubic feet. Okay, but we are not doing pounds per day per cubic foot. We are doing pounds per day per 1,000 cubic foot. Okay, so now to get per 1,000 cubic foot, you divide 33,166 by 1,000. And for the sake of this, since it's such a large number that we're using here, I did round to the nearest tenth. So that would be 33.2 thousand cubic feet. Okay. 1,501 pounds per day divided by 33.2, 1,000 cubic foot gives us 45 pounds per day per 1,000 cubic foot. That is organic loading to a trickling filter. Okay. Grades 1 and 2, Class C. You guys can stop listening if you'd like, but I do recommend you stick around because I think it's important you understand this. Grades 3 through 5, listen up. You've just solved the problem. You click to the next screen. Now, tell me if this is a high or a standard rate trickling filter. If you don't know the answer to that, you need to go study trickling filters. This is going to be a high rate trickling filter. Check out my whiteboard on my trickling filter video link at the end of this. You just click on it. Go watch that. I tell you all the values, hydraulic loading and organic loading. Okay. Another thing they might say is, okay, grades 3 through 5, congratulations, you got that answer correct. But this is a standard rate trickling filter by design. It is not a high rate trickling filter. What do? And you're going to have multiple choices. My guess is if you had that question, it would be, I need to put a second standard or maybe even a third, depending on what your loading is, trickling filter online in parallel, okay? And if they don't give you the dimensions where you'd have to add these values together, you would assume that the dimensions are all probably gonna be the same. That's pretty typical. You're not gonna have mismatched sized trickling filters right next to each other for the most part, unless there was a plant expansion or something happened of that nature. So the other things you might get if you get low, like say I got 6 pounds per day per 1,000 cubic foot, grades 3 through 5, you might be asked, are you nitrifying? Do you know? Do you know the answer to that? Because if you don't, you need to go study your trickling filter material. You would be nitrifying more than likely if you were 6 pounds per day per 1,000 cubic foot. And that was covered in my whiteboard as well. So I hope that helped people. Grades 3 through 5, be ready for those curveballs. This is going to be, the grade 4, when I took it, almost seemed like there were a few math problems. There was like the math segment, but then there was math problems kind of mixed throughout the test, and I would get one and I would solve it, and then I'd move to the next, and I'd have like 1 or 2 questions about it. They'd be kind of quizzing me on it. That was my experience anyway. So just be ready for that stuff. Anyway, questions, please put in the comments below. If you got anything out of this, like, subscribe, pass to your friends. Let's help folks get certified, and I will catch you guys in the next one. Have a great day.